Hello, this time I'm going to talk about semiconductor device review part 2, and I'm going to talk about PN junction, and I'm going to my organization note. What we're going to talk about is PN junction, and when we usually talk about PN junction, there is a square, and the left part is N-type, and the other part is P-type, and we usually talk about N-type. There is the part when the electron is fully occupied and there's less holes, and the p-type is where there are lots of holes and there are less electrons. When we see the symbol of the diode, we can easily know that the current can only flow to one direction. So therefore, the forward bias, when it is forward bias, the graph goes exponentially, and about the reverse bias part, it goes like close to the zero. Another part we need to look at closely is about the band diagram of NP semiconductor, and the top is the vacuum energy level, and the middle is the conduction band, and the lowest part is the valence band. And the distance between the vacuum energy level and conduction band, we call it electron affinity. And the distance between the vacuum energy level and the valence band, we call it ionization energy. Also, the distance between the electron affinity, the distance between the conduction band and the valence band, we call it the band gap, and all of the parts, we call it forbidden band. And about the Boltzmann tail, we call it that each the carrier concentration in the each energy, and how we know the carrier concentration is about the ferrum level and the density of states. And when we integrate the Boltzmann tail with the energy, we can get the concentration in that distance.